Hey everyone, and welcome to today's explainer. Look, if you're a focused learner trying to literally upgrade your AI's brain, really master data ingestion, you are in exactly the right place. Today is all about Retrieval Augmented Generation, or RAG, and more specifically, how we prep our data for it. So grab your notebooks, because we're going to make this super clear and structured.
Right out of the gate, we've got to tackle the ultimate question. It's literally the exact challenge every single AI developer is wrestling with right now. How on earth do you optimize your LLM token usage but actually boost accuracy at the same time? Sounds like a paradox, right? Usually you trade one for the other. But the secret sauce, it's all about how you slice up that data before the AI ever even sees it.
Okay, let's dive into this. What we're looking at is basically the complete landscape of RAG chunking strategies. Think of this as our roadmap. We're going to conquer these 6 specific methods today. We'll start up there on the top left with the most straightforward, basic approaches, and then work our way all the way down to those highly advanced, next-generation autonomous pipelines on the bottom right.
So here's how we're going to break this all down today. First, we'll look at the power of chunking. Then we'll build the foundation with fixed and semantic strategies. After that, we'll tackle complexity using recursive and hierarchical methods. And finally, we'll wrap up with adaptive chunking, looking at modality and agentic approaches.
All right, let's jump right into part 1, the power of chunking and why it actually matters for RAG. Before we get into the how, we really need to nail down the why. Getting this chunking strategy right is absolutely crucial. It's the secret to superior performance in your AI application. There are 4 major stakes here. Number 1, it improves retrieval accuracy, meaning your system actually finds the right info. Number 2, it cuts out the noise by reducing irrelevant results. And because that retrieved data is just better, it directly enhances your LLM's response quality. Finally, it optimizes your token usage and your costs. I mean, you definitely don't want to be paying the AI to process garbage data, right? Better inputs literally equal better, cheaper outputs.
Moving on to section 2. Let's lay the groundwork with our foundational building blocks for data ingestion, fixed and semantic chunking.
First up, we have fixed size chunking. Honestly, this is kind of your brute force method. You're just splitting text into chunks of a fixed length with a little bit of overlap. Imagine taking a paper cutter and just chopping a document evenly, say every 500 words, and then dropping those uniform pieces straight into the vector store. It's incredibly fast, it's very rigid, and it takes barely any computation.
So when do you use this? Well, it's really best for general-purpose applications, super fast ingestion, or when your data is already highly uniform. But here is a massive tip for success. You have to use overlap, usually around 10 to 20%. Why? Because if you just arbitrarily slice a sentence down the middle, the AI completely loses the context between slice A and slice B. That 10 to 20% overlap, that's what stitches the context back together.
Now let's step it up a notch to semantic-based chunking. If fixed size is a paper cutter, semantic is a scalpel. It gives you surgical precision. Instead of just counting arbitrary characters, we're actually splitting the text based on semantic similarity and context shifts. We're looking at the actual meaning of the words now. So, when the core idea shifts, bam, we make a new chunk.
Because this method is so focused on meaning, it is absolutely perfect for long documents and topic-aware retrieval. And to actually pull this off, the pro tip here is to use embeddings to detect those topic shifts. By analyzing the embeddings, the mathematical representations of the text's meaning, the system can literally detect exactly when an author moves from one topic to the next. It creates these highly intelligent logical splits.
Now, what's really interesting here is the direct contrast. On one side, fixed size chunking gives you these rigid, fixed-length splits that are super fast and general purpose. But on the other side, semantic-based chunking gives you meaning-driven splits based on actual context shifts. So you're basically trading the sheer speed of fixed size for the highly intelligent, topic-aware nature of semantic.
All right, section 3, we're moving up the complexity ladder to tackle heavier, more highly structured documents with recursive and hierarchical chunking.
Which brings us to recursive chunking. This method recursively splits up the text until those chunks meet specific size or condition criteria. It's kind of like a branching tree. If a chunk of text is too big, it splits it. If those new pieces are still too big, it splits them again. It just continuously breaks down the text, layer by layer, until you hit the perfect conditions for your vector store.
Because of that, it's incredibly well suited for really complex documents that already have a hierarchical structure. And if you want the exact formula for success here,
You need to set your max tokens, your overlap, and crucially, your recursion depth. By explicitly telling the system exactly how deep it's allowed to go to find that perfect split, you handle those massive, complex documents effectively without just grinding your processing to a halt.
Next up in the heavyweights is hierarchical chunking. And this brilliantly illustrates how we can break a document down by its natural structural sections. Check out this simple 1-2-3 pipeline. The system looks at the overarching title. Then it breaks that down into sections, and then it breaks those down into individual paragraphs or chunks. It maps perfectly to how we as humans naturally organize large text files.
Naturally, this approach is best for highly structured docs, think operating manuals or massive product catalogs. But here is a huge pro tip. You absolutely have to preserve the hierarchy metadata for better context. If you just extract a random paragraph without keeping the metadata about what section or title it actually belongs to, the LLM isn't going to have a clue about the bigger picture. You've got to keep that context intact.
Okay, we made it to the final chapter. Section 4, Adaptive Chunking. We're looking at modality and agentic approaches, the real next-generation AI pipelines.
First up in this tier is modality-specific chunking. This is where we extract and chunk based on the actual content type. We're separating text, images, tables, the whole shebang. Because think about a modern PDF, right? It's not just words. You've got charts, you've got graphs. This multi-format strategy identifies those different modalities, splits them up, and processes them appropriately before sending anything into the vector store. Interestingly enough, according to our source, modality-specific chunking shares identical setup parameters with recursive chunking. It's totally ideal for complex docs and hierarchical structures, and you'll want to use that same formula. Set your max tokens, plus overlap, plus recursion depth. Even when you're parsing out completely different types of content, ensuring you have strict guardrails on token sizes and overlap is just absolutely vital for complex files.
And finally, the absolute pinnacle of our explainer today. Agentic chunking. This is where we let an AI agent autonomously decide the chunking method based on the goal and context. It uses this powerful three-step workflow. First, the agent works to understand the goal of the document. Second, it decides the strategy. So maybe it chooses fixed for one part of the text, but semantic for another. And then third, it acts to create those chunks.
To wrap up our technical deep dive, this agentic approach is absolutely best for dynamic use cases and highly adaptive pipelines. Basically, whenever you don't know exactly what kind of file your user might upload. The pro tip here, combine LLM reasoning with strict heuristics. By mixing the logical reasoning of a large language model with rule-based heuristics, you create the ultimate unbreakable solution for dynamic data ingestion.
So, we've covered the complete landscape today. We went from rigid, fixed-size slicing all the way up to fully autonomous agentic processing. And I want to leave you with this final provocative thought to mull over. Fixed, semantic, or agentic, which strategy will you implement to power your next vector store? Think about the specific data you're working with, weigh those trade-offs between sheer speed and deep intelligence, and go build something amazing. Thanks so much for joining this explainer, and keep learning.